Well, first of all, looking at a simple diagram of an asset call, and actually notice that the convention in this chapter is that a cash call pays $1. So this graph here is actually 40 cash calls. So one can imagine that a single cash call would pay $1, and it would have a payoff function down here somewhere. So the payoff diagram that's in the chapter is actually representing, on the one hand, an asset call. That's correct, because obviously for each value of the stock price above 40, because the entire stock is being paid, the holder of the option is getting value equal to the value of the stock. And then we have here 40 cash calls. We can produce a comparable diagram for puts. And let's say we have a K here. And that is, first of all, if we wanted to look at a cash, an asset put, it would have a payoff function that looked like this. And so that this would be an asset put. This is an asset put in the solid line. Why is that logical? Well, remember, when the stock price is below K, the investor gets 1 share of stock, and so the value of that, of course, is just the value of the stock. We can look at one cash put pays $1 in this case, so one cash put would be actually down here. And comparably to the prior diagram, we could look at 40 or K cash puts, and that would have a payoff function up here. So 40 cash puts, or K cash puts in this example, would have a payoff of K dollars when the stock price is below K. So now let's look at the connection between all or nothing options and the vanilla options. And not surprisingly, if we wanted to create a vanilla call or an ordinary call with a strike of K, well, what happens, if you think about it, with an ordinary call? That gives the holder the right to buy. And what that means is that when the stock price is above K, the holder of the option is going to receive S and is going to pay K. And that's what we see here. That a vanilla call, we want one asset or nothing call with a strike of K, and we want to be short K cash or nothing calls. We want both call options because we want both parts to be in effect when the stock price is above K. And in particular, we want to receive S, so we want to be along the asset call, and we want to pay K, so we want to be short K cash calls. And then you can also see that by simply putting in the appropriate coefficient, you have the one long position in the asset or nothing call, you have the short position in K cash or nothing calls, and you end up with exactly the Black-Scholes formula. A put is exactly the same. Again, think about what happens with a put. When stock prices are below the strike, you have the option of selling the stock. That means you receive K dollars and you pay 1 share of stock. So again, one sees that we can reproduce a plain vanilla put option by going long K cash or nothing puts and shorting an asset or nothing put. The short asset or nothing put will require the payment of S. The long K cash or nothing puts will provide a payment of K. And again, you can put together the pieces. Here we have K long positions in cash or nothing puts. We have a short position in an asset or nothing put, and we put those pieces together, and lo and behold, we get a Black-Scholes formula. We can also look at the gap calls or the gap puts. You remember the gap options, and the idea of a gap option was that it split the function of the strike price K in a vanilla option into two functions. And that is that K in a vanilla option does two things. It determines the value of the payoff, and secondly, it determines when a payoff is made. And the gap option separates those functions, and that is, in the notation of the book, we have a K1 and a K2. K2 determines the event of payment. K1 determines the amount of payment. And so in a gap call, we pay S minus K1 if S is bigger than K2. Remember that gap options are not really an option because the holder may end up actually getting paid a negative amount. In other words, the holder may be required to make a payment. And so this is not truly an option. The holder doesn't have the right to choose whether they exercise or not. They're required to make the payment of S minus K1 if S is bigger than K2. Obviously, if K1 and K2 are the same, we get a vanilla call. Well, again, we can think of this as a combination of all or nothings, and that is that if we have just an all or nothing asset call, that's going to provide us the yes, and then we need to be short K1 cash calls. And both of those all or nothing calls need to have a strike of K2 because K2 is determining the event of payment. In a put, it's exactly the same thing. A gap put option pays K1 minus S when S is less than K2. Again, it's an obligation that that payment is made or received. There's no optionality in this. And once again, what we want to do is we want to be long in order to receive K1 dollars. We want to be long K1 cash puts with a strike of K2. And we want to be short one asset put, again, with a strike of K2. K2 is what identifies or defines the event of payment.